So this is week 11 of Physico Chemical processes for wastewater treatment. So this is online live session for the course offered by Professor V.C. Srivastav from IIT Roorkee, and I am the TA for this course. I am Vaibhav Kabadwal, a PhD scholar from IIT Madras. I am pursuing PhD in the Department of Civil Engineering, and my discipline is Environmental Engineering. So this week we will study about disinfection. So we will solve few questions, and we will see few MCQs also. So here is a question. What amount of chlorine is available in CaOCl2, CaOCl2 and NaOCl? So the question is asked like what amount in percentage of chlorine is available in these three compounds. Let's see. So for this we should know about what is percentage available chlorine. So the formula for percentage available chlorine is equivalent weight of chlorine in compound to the equivalent weight of compound. So this is the formula. So let's solve it for first. So for this we should be, for solving this question, we should have following things. We should have molecular weight, we should have equivalent weight, we should have reactions, redox reaction, and molecular weight, equivalent weight, redox reaction. Yeah, that's it. So we should have this much data for a compound. So now we will solve it for CaOCl. CaOCl2. The molecular weight will be 40 plus oxygen 16 plus chlorine is 35.5 into 2. So it will be 40 plus 16 plus 35.5 into 2. It will be the molecular weight is 143 grams. So to calculate the equivalent weight, we should know the reaction. So I am writing here the reaction so that you can find in the appendix of the book if you want to know. So CaOCl2 plus 2H plus 4 electron will give 2Cl minus plus CaO plus H2. So here we can see the 4 electrons are transferred. So equivalent weight we can write it as equivalent weight is molecular weight divided by number of electrons transferred or number of electrons Yeah. Number of electrons transferred. Molecular weight was 143. Electrons transferred how many? 4. So equivalent weight will be 143 divided by 4. It is 35.75. 35.75 grams. So equivalent weight of compound is 35.75. Now we need to calculate equivalent weight of chlorine. So better I should have calculated here itself so that we don't have to repeat. Now we will calculate equivalent weight of chlorine compound. Equivalent weight of chlorine compound. So for that we have the reaction here, Cl2 plus 2 electrons gives 2 Cl minus. Here 2 electrons are involved. So equivalent weight of chlorine we can find it as equivalent weight of chlorine is molecular weight by number of electrons transferred. This will be 35.5. We can write into 2 because 2 molecules of chlorine divided by number of electrons, so 2 electrons transferred. So equivalent weight of chlorine is 35.5 grams. So, the formula for percentage available chlorine is equivalent weight of chlorine, equivalent weight of chlorine in compound divided by equivalent weight of compound. So this will be equivalent weight of chlorine in compound will be 35.5 divided by what was for CaOCl2 35.75. We should multiply it by 100. If we solve it, how much we will get? 35.5 divided by 35.75 into 100 will get 99.3. 99.3%. So this was the first question. For second question, Second question was for CaOCl2. CaOCl2. So molecular weight of CaOCl2 will be calcium 40, oxygen 16 plus 35.5 into 2. Let's calculate it. 40 plus 16 plus 35.5 into 2 divided by. So it will be 127. 127 grams. And then we have the equation here for CaCl2. CaOCl2. Let's see. CaOCl2 plus 2 electrons. CaOCl2 plus 2 electrons gives 2Cl minus plus Cl. So here 2 electrons are involved. So we can write equivalent weight of CaOCl2 will be molecular weight by 2. How much it will be? Will be molecular weight was 127, I think. Yeah, 127 divided by 2. It was 63.5 grams. So percentage available chlorine for CaOCl2 will be given by equivalent weight of chlorine in the compound, that is 35.5 divided by 63.5 into 100. So we get 35.5 divided by 63.5 into 100. It is coming as 55.90%. 55.90%. Now the third question is for third part was for NaOCl. NaOCl. Molecular weight of NaOCl is sodium is 23, oxygen is 16, plus chlorine is 35.5. 23 plus 16, 23 plus 16 plus 35.5 is 74.5 grams. Then we have the equation NaOCl plus H plus 2 electrons gives chlorine ion plus NaOH. So here two electrons are transferred. So the molecular weight will be, sorry, equivalent weight. Equivalent weight will be molecular weight by number of electrons transferred. It would be 74.5 divided by 2. So it is 37.25 grams. So percentage available chlorine in NaOCl will be 35. Equivalent weight of chlorine in compound. The equivalent weight of chlorine in compound divided by equivalent weight of compound. Equivalent weight of compound. So equivalent weight of chlorine in compound is 35.5 divided by equivalent weight of compound is how much? 37.25. Five divided by 37.25 into 100. So it is coming as 95.3%. 95.2%. So this was the question for these three compounds, for CaOCl2 and for CaOCl2 and NaOCl. Now we will solve few MCQs. Disinfection is used in water treatment to reduce gas to an acceptable level. So what we reduce? So we reduce pathogens to an acceptable level. So hardness, TDS and total organic carbon are not reduced by, up to some extent we can reduce some organic carbons, but specifically they are used for removing the pathogens. In the reactions of chlorine with ammonia during the disinfection process, the distribution of reaction products is governed by the rates of formation of monochloramine and dichloramine. The rates of formation are not dependent upon. The rate will depend on pH, will depend on temperature, will depend on initial chlorine is to ammonia ratio, because we have seen in the graph it depends on chlorine is to ammonia ratios. This was residual chlorine, applied chlorine, This we have seen. It will depend on the chlorine to the chlorine to ammonia ratio also. It so are not dependent upon. So the answer is color. It doesn't depend on the color. Destruction of disease causing microorganisms is called. So if we are destructing, killing the disease causing microorganisms, so it is called disinfection. Destruction of all living organisms is called, it is called sterilization. So in general, we do sterilization. We don't, because in general we do sterilization only, because chlorine can't distinguish among pathogens and non-pathogens, or even any of the treatment technique. If we are using any other treatment technique, it's very difficult to find out which one is pathogen and which one is not non-pathogen. So generally we do sterilization only. A potable water is disinfected by 10 milligram per liter of HOCl and final measured pH is 6. Then what percent of HOCl is not dissociated? So given pK is 7.54 and temperature is 25 degrees Celsius. Solve it. And we need to solve it at pH. To the question, this is question 1. Question 2 is, what if pH is 7? So let's see one curve here. The curve is distribution. Distribution of HOCl and OCl as a function of pH. This you can find in Sawyer and McCarthy. So this is so in x-axis is the pH, and in y-axis, so in right hand side it is percentage OCl, this percentage OCl, and in left hand side it is HOCl. So the pH is varying from 4 to 11. 4 to 11, and there is 5 and 10. So the HOCl and OCl will vary like this. I make it more correctly. So this is at 20 degrees Celsius. This is at 0 degrees Celsius. So let's say this is at pH 4, 5, 6, 7, 8, 9. So the variation will be like this. So HOCl will be at pH 5 will be 100%, and this will be 0% OCl. So this is 50%. Likewise, it will HOCl will increase and OCl will increase in opposite direction like this. This is the curve. So at pH 5, HOCl is 100%. So if you are increasing the pH from 5 to 10, HOCl concentration will decrease to 0. Likewise, if we are increasing the pH, the HOCl concentration is increasing. You can see the HOCl will be 0 at pH is equals to 10. You can see OCl is 100%, and HOCl will be 0 according to the graph. So here, so what can we conclude? We can conclude if we are decreasing the pH, if we are increasing the pH, and the HOCl concentration is decreasing. If we are increasing the pH, the HOCl concentration is decreasing. So we will try to find out through these two questions. So if we are increasing the pH, the HOCl concentration is decreasing. So let's solve it. This is I will set it here. So we are given pKa. pKa is 7.54. So we can calculate Ka. K will be 10 to the power minus 7.54. The value of Ka we can write it as. So first we need to know the equation. HOCl will give us H plus OCl minus. It will be K will be H plus OCl minus divided by HOCl. So we know the pH. We know the pH. pH is how much? pH in first question pH is 6. In second question the pH is 7. So This is 10 to the power minus 7.54, 10 to the power minus 7.54, and pH was 10 to the power minus 6, and here it is OCl minus by HOCl. So here we can solve it and see 10 to the power minus 7. So HOCl is 34.67 times of OCl minus. So we can write like percentage of HOCl available will be HOCl percentage. We can write it as HOCl by HOCl plus OCl minus. So it will be HOCl. HOCl will be 34.67 OCl minus plus 34.67 OCl minus plus. So if we solve it, how much percentage I will get? It will be into 100. 34.67 plus 1 into 100. So the answer will be 97.19. Now we need to solve at when pH is equals to 7. So we can see percentage HOCl available is this much and not dissociated or not available. Not dissociated or not available. What was the question? Not dissociated. So not dissociated will be 100 minus 97.19 percentage. That will be 2.85%. Now we need to solve it for p is equals to 7. So we know k is equals to 10 to the power minus 7.54 is equals to h plus OCl minus divided by HOCl. Here we know 10 to the power minus 7.4, h plus is 10 to the power minus 7. So if pH is this, pH is minus log of h plus ion concentration is equals to 7. So h plus will be 10 to the power minus 7 mole per liter. So HOCl equals to 10 to the power minus 7 plus 7.54 into OCl minus. 3.467, 3.467 of OCl minus HOCl. So if we try to calculate percentage HOCl, we will solve it like HOCl divided by HOCl plus OCl minus. HOCl will be 3.467 of 3.467 into OCl minus divided by 3.467 of OCl minus plus OCl minus will be 3.467 divided by 3.467 plus 1 into 100. 77.61 percentage. So we can say at pH equals to 6 to pH is equals to 7. It was 90, how much percent was available? 97%, approximately 97% was available, and 97%, 97% available, and 77.61% available, 77.61% is available. So we can see from this graph also, so if the pH is increasing, HOCl concentration is decreasing. So the same thing we can see from the equations also after solving. So when pH increased, then efficiency of HOCl is decreased. And here not dissociated will be, you can calculate it, you can subtract it from 100 and you can report that like this much percentage not dissociated. Resistance of organisms towards disinfection depends on, so it depends on type and subtype of organisms present and the number of organisms present, their quantity means what is the initial value. The physical and chemical characteristics of water means water quality parameters like temperature, amount of suspended solid, organic matter present, the type of disinfectant used and the form in which it is used, the amount of disinfectant applied, how much quantity you are applying, and the time period for which the disinfectant is applied. So that is contact period. So how much is the contact period and how much is the quantity. HOCl and OCl these are actually free form of chlorine. Chloramines are combined form of chlorine. The sum of concentration of free chlorine and combined chlorine is called total chlorine. Total residual chlorine. Total residual chlorine. Because it is residue after the disinfection work. One method for removing taste and odor is by addition of chlorine in a process is called breakpoint chlorination. because what will happen after this after this break after this break point, the taste and order will there will be no taste and order, no taste and order. So this is chlorine applied, residual chlorine. So there will be no taste and order after this breakpoint chlorination. How chlorine inactivates microbes. The chlorine penetrates the bacterial cell wall and adversely affects the respiratory, transport, and nucleic acid activity. So this is how chlorine inactivates microbe. How does chlorine dioxide cause inactivation? So it disrupts the protein synthesis of the microorganism. How does ozone cause inactivation? So physicochemical damage to DNA appears to be the mechanism of inactivation of both bacterial cell and poliovirus. So this includes attack on bacterial membrane, disruption of enzymatic activity and nucleic acids. This is a complex mechanism find out the to find out how ozone inactivates microorganisms. So they are saying appears. How does UV radiation cause disinfection? So DNA of microorganisms. So here what we do is like, so the DNA of the microorganism absorbs light in the UV range primarily between 200 to 300 nanometer. So UV light is mostly absorbed by the DNA at 254 nanometer. We can say 254 nanometer. So if the DNA absorbs too much UV light, it will be damaged and will be unable to replicate. So if DNA is damaged, so it cannot replicate. So means there will be no further growth or reproduction. So it has been found that energy required to damage the DNA is much less than the required to destroy the organism. So the effect is same. If a microorganism cannot reproduce, so it cannot cause infection. So the UV means it just destroys the DNA and does its work. Destroys. What are disinfection byproducts? As the name suggests, disinfection byproducts. So disinfection byproducts are organic and inorganic compounds that result from chemical reaction between organic and inorganic substances in water during disinfection process. So during disinfection, when disinfectant reacts with organic and inorganic substances, so which some byproducts which are formed, these are called disinfection byproducts. These can be with organic and inorganic both. What are disinfection byproducts when chlorine is used as a disinfectant? Chlorine reacts with natural organic matter to form a number of carcinogenic, remember this, carcinogenic byproducts. So it forms carcinogenic byproducts. So these are trihalomethanes, haloacetic acids, haloacetonitriles, haloketones, haloaldehydes, chloropicrin, cyanogen chloride, and chlorophenols. So the THMs means trihalomethanes and haloacetic acids occur most frequently and generally represent the highest concentration of organic contaminants. Are there any disinfectant byproducts from UV radiation? Irradiation? No, there are no known disinfectant byproducts that result from UV radiation. So Chick's law dash take into account the concentration of the disinfectant? No, Chick's law does not take into account. Chick's law does not take into account the concentration of disinfectant. If we see the Chick's law formula, Ln Chick's law states like this. It states first order the concentration will vary based on the first order kinetics. So initial value will be n naught, then it will vary with time. So d and t by dt will be will depend on n naught, sorry, n, and then if we solve it, then we will get it n naught is equal to n t to the power minus kt. So it does not depend on the concentration. So this is the disadvantage of Chick's law. So that's why we may use Chick-Watson law. So Watson suggested to take the concentration into account. So let's see that. So what is Chick-Watson law? So Chick's Chick-Watson's law take takes into takes into account the concentration of disinfectant. So it takes care of concentration because if you are adding less concentration of disinfectant and more concentration of disinfectant, so it will vary the kinetics. It can change the pattern of the graph. So that's why it is necessary to take the concentration of the disinfectant. It is obvious that disinfectant concentration has a marked effect. Yeah. Watson proposed an alternate expression to describe a given level of inactivation. So he told like C to the power n into T will be constant. C is the concentration, n is the coefficient of dilution, and T is the time. So both can be combined like this. So K is equals to K6 K6 K for 6 constant will be K of 6 Watson into C to the power n. So the Chick's law, we can write it like this: n by n naught is equals to minus kt. This is Chick's law. So, but we want for Chick-Watson's law. Chick-Watson's law will be ln n by n naught is equals to minus, so kc, so here it was kc, so kc we can write as kc Chick-Watson's into c to the power n into t. So this is Chick-Watson's law. So here kcw is the rate constant of inactivation independent of concentration. Rate constant of inactivation independent of concentration. Its unit will be time inverse. How UV dose is calculated? UV dose is calculated. So UV, the formula is the dose of UV is equal to I into T. I is the average intensity. Milliwatt per centimeter square, and T is the average exposure time. Average exposure time in seconds specifically specified. What properties a disinfectant must possess? So these are the properties properties which a disinfectant must possess. It must destroy the all kinds and numbers of pathogens. So all kinds and numbers of pathogens. So this is the property. It may be introduced into water within a practicable period of time over an expected range in water temperature. It must meet possible fluctuations in composition, concentration, and condition of water to be treated. It must meet the requirement of fluctuation in composition, concentration, and condition of water to be treated. It must neither be toxic to humans and domestic animal, nor unpalatable or otherwise objectionable in the concentration required for disinfection. Its strength concentration, so unpalatable means not pleasant to taste. It must neither be toxic to humans and domestic animals nor unpalatable or otherwise objectionable in the concentration required for disinfection. Its strength or concentration in the treated water must be determined easily and quickly. Their cost must be reasonable. The cost must be reasonable, means it should not be too costly so that we can't afford. Because we have to treat the wastewater for a whole for the whole community, so it should be reasonable. So what are the characteristics of an ideal disinfectant? So these were the properties of these were the properties which a disinfectant must possess. So this question is, what are the characteristics of an ideal disinfectant? So the ideal disinfectant should be and safe to store, easy and safe to store, transport, and handle and apply. Provide some residual. So it should provide some residual so that it should persist for sufficient concentration to provide reasonable residual protection against possible recontamination. So in future, if further recontamination happens, so it can take care of that also. So that's why we want some residual. So chlorine can provide residual in the form of combined chlorine when it reacts with ammonia. The disappearance of residual must be a warning that recontamination may have taken place. So if the residual decreases, if disappears, so it's a warning that recontamination has taken place. Select the appropriate disinfection strategy. Select the appropriate disinfection strategy. So the strategy contains three points. So the disinfection strategy have must consist of water which should be free of pathogens, and it should avoid production of disinfection byproducts. So if we are going to plan for disinfection unit, so our strategy should be that water should be free from pathogens and avoiding disinfection byproducts, because in the previous slides we studied disinfection with chlorine can cause carcinogens by it can produce carcinogenic byproducts. Maintaining a disinfectant residual in the distribution system. So we do it to prevent or to safeguard from future recontamination. Like if we see the example, suppose this is a treatment plant. So the last unit is disinfection unit. So from here you have treated the water and you are going to supply. So this is supply. So treatment is done in the treatment plant. So here there is no treatment. But if the water pipelines are in the soil, these are below the ground level. So from the soil itself, if there is any leakage or something, so the water may get further recontaminated. So to prevent the future recontamination, we should have some chlorine residual. So that's why we should have some residual chlorine or residual disinfectant. The objective of primary disinfection is to achieve microbial inactivation. So the primary disinfection, so we have two types of disinfection. One is primary disinfection, which is done to achieve microbial inactivation. And the secondary, the secondary disinfection is to think the objective of secondary disinfection is to provide disinfection residual in the distribution system. Disinfection residual in the distribution system, which I told earlier. This is the treatment plant. This is the treatment plant. After this, we are going to supply. So this here we need we need disinfection residual. Okay. Now we have one question. So the question is the chlorine consumption in the treatment of 10,000 meter cube per day of river is 6 kgs per day. So we are treating 10,000 meter cube per day of river water. And the chlorine consumption is chlorine consumption is 6 kgs per day. The residual chlorine after 30 minutes of contact is residual chlorine is 0.40 milligram per liter. So what we need to find it out. So we need to find calculate the chlorine dose in milligram per liter and chlorine demand of river water. We need to find two things: chlorine dose in milligram per liter and chlorine demand. So we need to calculate chlorine dose in milligram per liter and chlorine demand. So we need to calculate chlorine dose and chlorine demand. So you think what is the difference between chlorine dose and chlorine demand? Both are same or different? If they are different, what is the difference? There is an issue. So we'll wrap it as early as possible. So there are two things: chlorine residual and chlorine demand, I think. Chlorine dose and chlorine demand and chlorine demand. So chlorine demand is the demand is the chlorine requirement to kill the microbes, oxidize the reduced compounds. This is the chlorine demand. And chlorine residual is the amount of chlorine required to form the combined chlorine. So we can say like chlorine dose is equal to chlorine demand plus residual chlorine plus chlorine required to form the residue. Chlorine required to form the residue. Chlorine dose is equals to chlorine demand plus chlorine required to form the residue. So these two things. Let's solve it. So we need to find first chlorine. So this is a dose only. Yeah, 6 kgs per 6 kg per ton. So we are going to calculate dose. Dose is how much dose? 6 kg, 10 to the power 6 milligram per day in 10 to the power how much? 10 to the power 4 meter cube. 1 meter cube is equals to 1000 liter per day. This much water is getting treated. So it will be 6 by 10. So it is 0.6 milligram per liter. The chlorine dose. So the chlorine dose is 0.6 milligram per liter. And residual, they have mentioned that residual is 0.4 milligram per liter. Residual chlorine is 0.4 milligram per liter. So we need to find how much is the chlorine demand. So we know that the chlorine dose is equals to chlorine demand plus chlorine plus residual chlorine. Chlorine dose is equals to chlorine demand plus residual chlorine. So here we can, so the first part is over here and the second part is chlorine demand. So chlorine demand is written as chlorine dose minus residual chlorine. So chlorine dose was 0.6 and residual chlorine was 0.4. So if we solve, we will get chlorine demand as 0.2 milligram per liter. This is the answer of this question. Okay.